SwayamPrabha. Digital India. Educated India.
Hello everyone. So, we will continue with water filtration, like how textile fabric protect us from water pollution, and in this module we will discuss the different types of membranes used in controlling the water pollution, and also one detailed research studies where we have developed water filter. First, let us try to understand what is water filtration. So, because water filtration is the process of removing or reducing the concentration of particulate matters. So, we have to remove altogether, or also we sometime, if it is not possible in one stage, we try to reduce it. So, the particulate matters, different types of particulate matters. Now, let us see what are the particulate matters are there. These particulate matters are harmful for basically human being or maybe aquatic animals, and overall it will have environmental impact also. So, let us see the particulate matters are basically in the form of suspended particles. You can see here like a soil, in the water these particles are suspended, soil particles are very fine particles are suspended, and these particles get settled, sedimented at the bottom, but it takes time. So, larger particle settles quickly, but smaller particles will take time. So, this suspended particles which are not actually in the solution, that particles will take time to settle, and this particulate matters we need to filter out. These are basically typically at larger size particles. So, physically we can remove it. Then in water we get the parasites, different types of parasites. You can see in water it is there. We must remove these parasites which are harmful for human health. Next is bacteria. So, it is very commonly available pollutants and harmful for human consumption. So, this bacteria we must remove physically, or we must kill before we consume this water. So, this bacteria is very common pollutant, very common matter present in the water. Then algae, you can see that it is very commonly used in that available in particularly in stagnant water. So, in stagnant water we see that the algae, if we want to use this water, we must filter, use water filtration, otherwise it is harmful, and viruses are available present in everywhere, in the air, in water. So, in air filtration we have seen how filter can prevent restrict virus spread. So, similarly in water filtration we can also filter out viruses from water and get clean water. Then fungi is there, which are very common in particularly in stagnant water, and this fungi are very harmful for human consumption. So, apart from this, there are different undesirable chemicals or biological contaminants like your volatile material which are actually present in water. So, different types of salts, different chemicals, biological contaminants are there, which we need to remove before we consume that water. So, all this they contaminate water. So, we will see, we will discuss how to actually remove all this, how to filter out all these particulate matters, even if it is, these are very small particulate matters like virus, bacteria. So, even a salt, even this some chemicals we can filter out. So, those technologies we will discuss, processes. So, first let us see, before we design our filter, we must know our contaminants. So, these contaminants basically are filtered out based on their size. So, we can see here these are commonly available contaminants in water. So, as I have mentioned, the suspended solids, these are basically 10 to 100 micron size, which just let us go back, this is the suspended solid, here the size is typically 10 to 100 micron, larger size, and see parasites and bacteria 1 to 10 microns. So, bacteria are a little bit smaller in size, typically around 1 to 5 microns. Okay. So, you can see here these are the parasites and bacteria. So, these are the size is 1 to 10 micron typically, and then you can see virus, colloids. Okay. So, organic material. So, these are sizes 0.01 to 1 micron size, these are typically virus, and so their size is very small, 1 to 0.01 to 0.1 micron, and then different types of dissolved salts and essential minerals are also there. So, we have to see whether we want to remove all these salts or not. So, depending on that, we have to select our water filter. So, dissolved salt whose size is that 0.001 micron, and here up to 0.001 microns, 0.0001 to 0.001 micron. That size is a very small size. So, we select our membrane, we select our filter depending on the size we are targeting. So, you can see here liquid filtration is required to separate various contaminants present in aqueous solution or hydrocarbon liquid, so that we can get them in pure form. So, it is done in two ways. One is, suppose this is the a liquid, so water, suppose this is water, we want to drink this water. make it drinkable. So, particles are there. In this case here it is these particles are undesirable. Here we have to use the filter to remove, to block all this particle and to get clean water. This is clean water without particle. So, this is one type of filter. Now, in another filter, particularly in used in food industry or various other chemical industries, where we want to separate out the required ingredients in the pure form. So, that in that case the fluid is not required, the solid particle is required. So, in that case, suppose this is the one solvent is there and we want to retain the particles here, we want to retain this particle, suppose food item or any other item. There we remove all this liquid part, this is suppose filter press, here the fluid is not required. So, hydrocarbon liquid is there, it is now what remaining is that these particles. This is the actual pure particle which is maybe food item, maybe anything. So, that type of filter is also used in the industry. So, liquid filtration is done in two ways. The examples, water purification, which is basically our topic of discussion. We want to purify the water for human health, human protection. Then aqueous food filtration, like food item is actually in a suspension with the water. So, we want to remove the water and get the pure form of food item. So, that way we can use the water liquid filtration, like beverage filtration. So, we can use that filtrate, that we can separate out the fluid. Blood filtration. So, from the blood, what we want to keep the like platelet filtration, or we want to keep the blood the components, different components we separate out. So, there blood filtration is important. Edible oil filtration. So, we just want to extract oil from the seed or the solid particle which will be separated, the cake in the cake form, and the liquid part, the oil, there this type of filtration is required. So, there are different types of filtration are there, liquid filtration, but our concern is water purification, that we will concentrate on our discussion on water purification. So, also you will see the fuel filtration. Fuel filtration is there in the petrochemical industries or oil industry. So, there we can filter the oil from the crude oil. So, this to get the pure oil form. So, here liquid filtration may be defined as the separation of solid from liquid. So, that is the liquid filtration. separation of solid particles. So, liquid the solid particles are suspended maybe in at various size, as we have discussed different types of solid contaminants. So, we are trying to separate the solid from the liquid by passing through a permeable medium, which will allow the particles to get trapped and the liquid to pass through. So, that is that type of permeable medium is required. For that, in some cases we need higher pressure, particularly in RO. So, where the pore sizes are very small. So, in that case we need some pressure, and the filter medium which will retain the particles. Okay. So, that is the liquid filtration. Now, we can see the schematic diagram here. Here this is the suspension is there. In the suspension, if you see, this is the say suspension here, and your flow is there here. In the suspension with the liquid, there are particles here, okay, and we are applying some pressure. So, P1 is the upstream side pressure, here P2 is the downstream side pressure. So, P1 minus P2, that is pressure drop, driving force. This is the driving force which will drive the liquid through this filter medium, that may be filter fabric, nanolayer, maybe different types of membrane. Okay. So, here when it is flowing, it will restrict all the particles and through this particle, and then it will allow only the liquid to pass through the porous membrane. So, this is basically the filtration. Here we need a flat membrane, and the particles will get settled in the top side here, okay, in one of the sides, and here it will be clean. Now, depending on our requirement, we can select the pore size, and accordingly the different particles are there. Suppose in water, as I have seen, we have discussed that it is actually mixed of many large particles, small, virus, bacteria, salt. Suppose we do not want to retain the, we do not want to restrict the salt to flow through, and salt, the dissolved salt, there the diameter is very small. So, we can select a filter or membrane with a pore size is more than that salt size. So, differential the selective restriction we can maintain here. So, as we have mentioned, for any filter we cannot block the pores. We cannot filter with a completely coated impermeable membrane, we cannot filter. So, because the liquid has to flow through, same is true for air filtration. So, there we have to create a filter with some apertures. The fine apertures are required and necessary for filtration, that is the fluid to flow through. If the fine apertures are not there, it is blocked, then the filtration process will not be there. It will only contain the fluid, contaminated fluid. So, this apertures can be provided by the cloth filter fabric, by mesh or screens of plastic or metal, like nylon mesh is available, nylon filament mesh. For liquid filtration we use nylon mesh or metal mesh is, they are very commonly used. Okay. And soil beds we use for liquid filtration. It is basically, it will give the coarse filtration, like you see here, this is a contaminated water is moving, and here we can create a soiled bed, okay, which is porous in nature, and it will allow the fluid water to pass through, but large contaminants will be restricted. So, soil bed solid particle beds we can use, maybe by sand, by soil, but anything we can use here. So, in some cases thin permeable coat, so preliminary coat we can use, okay. So, that we can use which is permeable in nature, or other fine particles. So, here we can use that a thin coating we can use, which is permeable coating, or we can have some fine particle coating. So, which is put on the cloth. So, that is the cake formation is done prior to filtration. Okay. So, main filtration is there, cloth will have main filtration, and then small fine particles are deposited, and that is used for filtration. Okay. Preformed cake, this is called preformed cake on the one surface. So, let us now try to see the what are the different types of water purification systems. You will see there are different types of water purification systems. So, first is coagulation or sedimentation. So, if you see, sedimentation is the first method where the large particles present, if you keep the water stagnant, this particle will get settled and the water will be relatively cleaner. Okay. And also coagulation. So, where we can coagulate the smaller particle into a larger particle. So, number of particles can get coagulated and then they will get sedimented. So, coagulation is also possible. Here we can use some chemical that we will discuss in detail for coagulation. We can do chemical treatment to deactivate the chemical, and then those chemical can get settled. Membrane technologies we can use, which is very widely used in modern water treatment plant or even for home water purifier. So, membrane technology is very commonly used nowadays, widely used in almost all areas, and in membrane technology there are different types of technologies available, like reverse osmosis technology, RO system, it is very commonly used, where the pore size of this RO, it is very small, smallest pore size available. So, here you can see 0.0001 micron, which that means we have seen the size that it can actually retain, separate out the salt particle present in the water. Sometimes the problem here is that in RO it will remove all the salt. So, make the water basically soft water, but salt sometimes it will harmful salt it will remove, but at the same time it removes the helpful salt from our end, which is required. So, that is the problem with RO, this we will discuss. So, RO typically the size of RO pores are 0.0001 micron, it is typically in nano size. Nanofiltration membrane, the size is little bit more than RO, 0.001 micron. Now, then you can see the ultra filtration, it is around 0.01 micron. Now, microfiltration, its membrane size, pore size is around 0.1 micron. So, if you see the particles are captured physically by the pore size. So, finer particle, finer than this pores size, the particles can flow through. Now, we can see here, I will just go back, see depending on the size. So, this is this type of particle RO can remove, RO can remove all this type of particles. Accordingly, so micro, ultra filtration are different types of micron, depending on the size it removes. So, bacteria size is 1 to 10 micron. Now, if we go forward there, we can see even the microfiltration can take care of the bacteria. So, all the filters are suitable for removing the bacteria, but in air filtration the main difference is that in air filtration the mechanisms are entirely different. In air filtration we have discussed the particles move at very high speed, sometime there will be inertial impaction and all different processes are there, but in water filtration basically the membrane, it depends on the pore size, okay. And then comes UV filtration. Through ultraviolet ray we try to kill all the germs, okay, and microbes. So, typically ultraviolet C, which is very dangerous for human being, luckily it does not reach to the earth, it ozone layer absorbs, but in UV purifier we generate artificial ultraviolet ray, UVC. So, that also is embedded sometime with the water filtration system. And then activated carbon. So, activated carbon impregnated textile fabric is used widely for water purification, for absorbing the volatile component and different removing the odor. So, that this type of activated carbon is very common. So, these are the different methods, and then for very large particles that we have mentioned, it is a sediment type. Sediment filter is used for larger particle. Now, let us discuss in detail one by one. First, coagulation and sedimentation. The coagulation process actually involves the addition of a chemical. We add one chemical in the coagulation, typically alum is used, and which produces the positive charges and neutralizes the negative charges of the particle. Okay. So, if you see, this is the here water and the contaminants are there, different types of contaminant with negative charge, and we use say alum, this is alum is used. Now, this all this negative, this is positive charge, and these particles will get attracted by the alum and form a larger particle, and that large particle can be removed by simple filter cloth. So, that is the process which is very commonly used. So, for any water, to clean water, we use alum. Okay. And these particles will stick together. Suppose this is the alum and the particles will stick on this surface, they will stick together and they will form a large particle. So, small particles cannot be removed efficiently by this process, because that very small particles will not be removed, because they settle slowly and they may pass through the filter. So, if you use alum, what will happen? They will actually, the large particle it will attract, because alum is, you have kept alum at the bottom, it is a large particle, and it will try to attract the relatively larger particle which are close to this alum, and they will form a larger particle. But the smaller particle which are floating will be, they will not get settled easily, that will take time. So, that is why for small particle it is little bit difficult. So, this is the first way of first stage of water filtration. Along with that, for smaller particle we have to use some other methods, different methods of water purification. Now, we will continue. The next is the chemical treatment. We can treat the water with different types of chemical to kill the harmful ingredient, harmful contaminants, like free chlorine or hydrochlorous acid is used very commonly. So, chlorine we put water for purification. So, chlorine is very effective against almost all bacteria, virus, cyst. So, they will actually, chlorine will help in killing this bacteria, virus, cyst. Okay. but the main problem is the chlorine is actually sometime use of chlorine in larger quantity continuously, it is dangerous and we have to handle it carefully. So, direct contact with chlorine can cause severe skin and respiratory irritation. So, chlorine, while using chlorine we must be very careful, or sometime we give the halogen tablet or household bleach or calcium or sodium hypochlorite, this type of chemicals we use, some bleach to create heavy the strong chlorine test, because that this type of actually an order in the tools. So, if we use the halogen tablet, that is chlorine tablet or some type of bleach just to kill this bacteria virus, but main problem is that this will create the taste, change the taste and smell of the water. So, that is why for drinking water we normally do not use nowadays this chlorine. Iodine also is very commonly used to treat water for water purification. So, it is one of the oldest form of water purification. So, it does a pretty good job. So, making the water safe from the bacteria virus. Okay. So, the main problem with this using the iodine in water purification is that it changes the taste, color, order. So, this all these changes will take place. So, and which we do not like this. So, iodine is very good easy way of killing bacteria virus, but it will change the taste of water and it will make the water little bit some color will change. So, it is often causing the water yellowing of water. So, that we may not like to drink. So, and it will change the taste also. So, but this will be safe for drinking because relatively safe because it kills most of the bacteria and virus. So, the major disadvantages of the chemical treatment are it purifies the water by using the carcinogen chemicals. Okay. And it is a that it will be byproduct generated in that will remain in the water. So, that is it will be the in the water the biocides will be there. So, that drinking that water may not be good without any extra filtration. Now, coming to the advanced water purification technologies, that is membrane technologies is very widely used. First is the RO purification. Let us see the RO purification. RO means reverse osmosis, which is most widely used in water filter. Here we use the semi permeable. So, it is a membrane with a very small pore size. So, as we have discussed, it will be the smallest pore size 0.0001 micron. at that level the pore size is created. The semi permeable micron, to remove it can remove the dissolved salt also, dissolved chemicals from the water, different types of impurities, germs from raw water. And raw water directly if you use, the problem would be that in the raw water, if the particles are from the dissolved water to large particle, if it is there, that type of range if it is there. So, large particles are also there. The problem would be that the membrane will get clogged very quickly. So, it will not perform its function properly. So, RO purification we can use only after the pre-filtration. So, where we need to remove the dissolved salt or very fine particles, then only we can go for RO filtration, otherwise the pressure requirement will be very high. So, the membrane has very fine pores, pore size I have already mentioned around this 0.0001 micron, that allow only water to pass through, leaving behind all the harmful chemicals, dissolved salt, microbes, virus, bacteria, everything it will be filtered out. That is a very small pore size. So, we can see that size of RO membrane approximately this, it is as low as 0.0001, but at that range we can see average micron, which is slightly larger than the size of water molecule. Now, we can see the water molecule size is smaller than 0.0005 micron. So, it will allow only the water molecule to pass through, but any other particle dissolved in water which is larger than this size will be restricted. So, it will allow the water to flow through. So, that is why it is a semi permeable. Now, try to see the RO purification system. Here the water is coming with all sorts of particles, okay, here, and this is the water particle, and through reverse osmosis through the membrane only the water will flow through this, leaving the, that is the, this shows the water molecule is only passing through, but all other membrane, all other matters are even suspended, any suspended solids or even the salts, dissolved salts are prevented from passing through this membrane. Now, we can see here these are the water particles, water molecule and mixed with the larger particles, okay. And here the size is say 0.001 micron. We have kept the size of this RO membrane 0.001 micron. So, here we can have, it will allow the water molecule to pass through easily and restrict all other particles larger than this size. And you can see here the large particle will get will return from after striking the membrane wall. Even when it is coming in front of the pore, it will be pushed out. So, here the in reverse osmosis system, the advantage is that the settling will not be there of the particle easily. So, that will they will actually get bounced back, keeping the membrane pores always open for water to flow through, because water is flowing through the reverse osmosis process by the pressure drop. Here pressure drop, pressure P1, this side P1 and this side P2, and that due to that pressure drop, this is this reverse osmosis takes place. Now, the size of reverse osmosis membrane, that pore, is approximately, in earlier we have discussed mentioned 0.0001, that is also possible, it is a smallest size, but general it is a 0.0005 to 0.01 microns. So, here the example is given 0.0001 micron size, okay, which is slightly larger than the size of water molecule. So, water molecule, if you see, this is the size of water molecule 0.000027522. So, that size, and we are trying to keep little bit larger than that. So, to pass the water through the RO membrane, okay, use water pump, because we need a pressure drop. Here P2, P1. So, P1 minus P2. So, that pressure drop has to be there. So, here we use pump. So, to create the pressure difference. So, we use here the water pump to pressurize the raw water, which is hard water. That means, here the salts are there, dissolved salts are there, that is why it is hard water, and this pressure drop helps in the water to pass through the membrane. Here we need a certain pressure drop. Now, during this process what happened, the dissolved solid like arsenic, fluoride, lead, chlorine, nitrate, sulphate. So, this all these particles dissolved salt, this they are actually the size is more than the pore size, and they are trapped or stuck in the membrane. So, that we have already discussed here. So, all these solids are stuck here, and then it allows the only clean water, purified water to pass through. So, through RO whatever water we get, it is a pure water, even it is a there is no dissolved salt is that. So, it makes the water soft water. So, from hard water to soft water we can get by RO. So, water coming out of RO membrane is also called desalinated water, that is there is no salt present there. So, RO filtered water pass through the post filter or through the carbon filter. So, RO has removed all the solid particles, but there will be some maybe some order may be there, okay. Some volatile compound will be there. So, that all for those it does not remove, RO does not remove the order or taste, does not change the taste. To change the taste, we can use the activated carbon. So, activated carbon filter we can use to change the taste of the water, which is coming out from reverse osmosis process. So, let us see what are the drawbacks of RO. RO can do a great thing in purifying the water, but there are some drawbacks. The main drawback is that RO requires high water pressure, and that some water is wasted in the rejection stream, that is important. In RO, whatever particles are accumulated in the upstream side, so that those particles has to be removed. So, reject stream should be there. So, here one is the high water pressure is to be created. So, we need additional pump for RO, and at the same time the wastage of water is there. That is the main drawback of RO. Like we can see, to purify 10 liters of RO, to get that 10 liters of RO purified water, approximately 5 liter is wasted. That means 50% of the water is going to waste in the rejection stream. So, that is the main drawback of RO. And also, if we do not want to alter the taste, because taste sometimes some salt and all other particle give the taste, it alters the taste of the water, and also it may remove some essential mineral which are helpful for our human body. So, you are drinking water without any salt. So, for long time it may affect the human health. That is the main drawback of RO system. And also the problem here is that it is the pore size is very small, okay. And here for this there may be some damages take place, and for that this membrane maintenance is very important. We have to replace the membrane frequently. So, here proper care has to be there, because this is a very sensitive membrane. It may get damaged with some physical action. So, that proper maintenance and care is needed, because the membrane is the main component in any RO system. Next process is the nano filtration purifier. So, this nano filtration purifier here, this is actually almost similar to the RO membrane, but here the pore size is little bit more than the RO. we can I will tell you that typical pore size, as we have already mentioned earlier. I will just go back. You can see here it is a little bit more than the RO system. Let me go now. Nanofilter membrane have slightly bigger pore size than RO filter, which has led the narrow, sometimes we call it a loose RO, loose reverse osmosis membrane, because the larger size, but it will allow the some salt to pass through, but it will restrict all other particles, even virus, bacteria, it can restrict that. So, nano filter membrane have smaller pore than ultrafilter membrane. So, next level is the ultrafilter UF membrane, and has the capability of remove larger dissolved molecule. So, it will actually like RO actually it can remove even the smaller dissolved minerals it can remove, but any larger dissolved chemicals that ultrafilter can remove. So, this larger dissolved chemicals like divalent molecules of calcium, magnesium, or other hardness causing salts. So, through nanofilter we can remove the hardness also, normal hardness. Okay. So, that is one of the important application of nano membrane is to soften the water. So, you want to, if you want to make the water soft, RO always we can use, but it needs higher pressure. So, that is why we use the, for softening the water we use the nanofilter, or to remove the waste. So, any from the water any hardness if you want to remove, and to make the water softer. So, in case of here in case of nanofilter, it will allow the monovalent sodium chloride component, but divalent components, as we have mentioned earlier, larger particles, divalent molecules like calcium, magnesium and other hardness causing material, it will restrict, but it will allow the monovalent component like sodium chloride. So, it will not allow the to pass the divalent salt like sodium sulphate. So, sodium chloride it will allow, but sodium sulphate it will not allow. So, that type of depending on the size, that type of selective filtration is possible using nano purification. So, all salts of heavier atoms like those in the toxic heavy metals are blocked by this. So, any heavy metals, salts of heavy metals, that those are actually of size more than the nanofilters pore size. So, this particles, this actually salts will be blocked. So, main difference, if we want to know the main difference, how the nanofilters are different from the RO. that RO blocks the monovalent salt like sodium chloride, whereas nanofilter allows it to pass through. So, as I have already mentioned. So, nanofilter has a larger pore than RO. So, nano water purifier can work on lower pressure than RO. So, RO needs higher pressure. So, as the nanofilter has got larger size pore size and RO smaller pore size. So, RO needs higher pressure, this is RO and nanofilter. So, here we need higher pressure or comparatively lower pressure drop. So, nanofilter we can use lower pressure drop because the pore sizes are larger than the RO. So, nanofilter membrane purify water from all toxic dissolved chemicals including heavy metal and all organic compounds. So, this is actually the all the toxic dissolved, because its size is also very small, only the monovalent salt it cannot restrict, but all heavy metals, all organic compounds it can filter out. So, it completely removes all microorganism, that because their size is much larger than this nanofilter pore, it including smallest viruses. So, bacteria it will anyway it will remove, but smallest viruses it can remove from water. So, this membrane is very important. So, nanofilter it works in lower pressure also, lower than the RO filter. So, nanofilter removes up to 60% of hardness causing salts like calcium, magnesium, water. But monovalent salt also creates hardness like sodium chloride, it cannot remove. So, at least 60% of the hardness will be removed, which is generally taking place. So, we will continue with this membrane and will this nano filter purification, that we will also continue with this segment in the next session. Till then, thank you.